Okay, so I'm going to do a quick review on the method of undetermined coefficients, which is something we learned at the very beginning of the semester. So say you're given an equation such as y prime prime plus 5y prime plus 2y equals 10x squared. We want to notice first off that this is a second order, linear, inhomogeneous differential equation. We see this right-hand side is not equal to 0. The general method we're going to do is to find a y that's a mixture of the characteristic equation and a particular solution. So we're going to start off by finding that's pretending it's homogeneous and finding the solution for that. So we set it equal to 0. We say that y equals e to lambda x, and we find the characteristic equation. Lambda squared plus 5 lambda plus 2 equals 0. Then we have lambda plus and minus is negative 5 plus or minus square root of 17 over 2. So we know that our equation for the characteristic equation, our solution is yn is c1 e to the lambda plus x plus c2 e to the lambda minus x. And if you need a review for this, we went over this right before we learned this method of undetermined coefficients. Next, we want to find a y particular. So we have a table of a bunch of kind of educated guesses that we can make. And this is a great thing to include in your cheat sheet because it's good to just be able to look at the equation and know right off the bat. So when we look at this 10x squared, we want to guess that our y particular is a cx squared plus bx plus a. That means that our this yp prime is 2cx plus b, and this yp double prime is 2c. Next what we want to do is plug these three equations, these three variables, back up here into the top, into this. So again, we have these three, and we want to plug them in. When we plug them in, this is what we get. This whole big thing here. And again, it's setting equal to 10x squared. We're no longer dealing with the homogeneous solution. We're going back to the original equation. So we can multiply these out to make sure we have everything right, and we end up with this whole equation right here, the one that's bracketed. So now what we want to do is we want to set the variables on the left-hand side equal to their corresponding on the right-hand side. Luckily, we only have one term on the right-hand side, and we see that we have one x squared term, 2cx squared equals 10x squared. So we have 2c equals 10, and c equals 5. Easy enough. Next, we look at the terms that multiply x. We realize we have none on the right-hand side, so that becomes 10cx plus 2bx equals 0. We already found c, we plug in for c, and easily get that b equals negative 25. Again, we do the last thing for terms that have no x in them. 2c plus 5b plus 2a. Again, setting this equal to 0. We already have b and c, so we easily plug in and find that a equals 115 over 2. So next, what do we do with these a, b, and c's? Well, we plug them into our y particular that we guessed, and we have 5x squared minus 25x plus 115 over 2 as this yp. Now remember, our eventual y general is a mix of this and the characteristic equation solution. So we want to first figure out what the c1 and c2 are in the solution in order to find those constants. So if we had some initial conditions, y of 0 equals 1 and y prime of 0 equals 0, we could easily satisfy those. So we know that our y general, which we didn't write, but we can easily write that here, y general is equal to this yp plus c1 e to the lambda plus x plus c2 e to lambda minus x. So if we know that y of 0 equals 1 and y prime of 0 equals 0, we have, for y of 0 equals 1, we plug in 0 up into here. All that we're left with is this 115 over 2, so that goes right there. And obviously when we plug in 0 into these two terms, we're just left with c1 and c2. Similarly, for y prime of 0, all that we get from the y prime term is a negative 25 for the particular part of the term. And then this is c1 lambda plus and c2 lambda minus, because remember when we take this derivative, this lambda plus comes down and this lambda minus comes down. Great. So then we have these two equations. Negative 113 halves is c1 plus c2, and 25 equals c1 lambda plus c2 lambda minus. Now I won't show the math here, but in order to find the c1 and c2, you'd plug in your lambda plus and your lambda minus and solve these equations. This is a bit much algebra, I think, even for the final, and we didn't have to do this on the first midterm. But just know that you could do it if you need to, but it would be a lot of algebra. So then eventually we end up with this y general solution. We have our particular solution plus the solution to the homogeneous equation, and that's what we end up with. I'm calling it yg, 5x squared minus 25x plus 115 halves, plus c1 e to the lambda plus x plus c2 e to the lambda minus x. This would be a great problem on the final because it's pretty easy to do in about 10 to 15 minutes, and it's very algorithmic, so as long as you know the steps, you should have no problem at all. Thanks!